Hello, hello. Right. All right. Hello, hello. Um, Welcome to the tutorial. I'm still waiting here for a few more of the students to join. Uh, if you can hear me, just write a quick message, something here in the chat box. If you and well, let's see. If you can't hear me, send a message to fds@utexas.edu. All right. So first of all, I'm going to ask you guys to edit your video streaming settings up here and just change the quality of the video to either 720 or 1080p. This way you'll be able to see what I'm pointing to when I point at some small pieces of text or small fonts throughout the text. Um, you'll be able to see a little bit more of what's actually going on. All right. So we have 3 people already. Actually, 2. One of these is me. Um, here. So if you can hear me, please just send a quick message here in the text box, just so I know that you guys are there and that I can start. I'm gonna give a few more minutes before we start. I'm seeing that another person just joined. I'll be starting. Hello, hello. Hi, Vo. Okay, so glad to see you guys can hear me. All right, we got yet another user. So it's 9:36. I'm going to start at 9:38. I'm going to give the other students two more minutes, and then I'll start the course. If you've just joined, hello, Suharit. Um, if you've just joined, please make sure to set your video qualities to high. Go in here, quality set to 1080p or 720p. This is because I'm going to be pointing to some parts and slides that have small fonts. So you might want to have these. You might want to have these too. Oh, okay. 3 more minutes. Okay, sure. Uh, you might uh, you might want to adjust the video settings just to make it just to be able to see the smaller print. Oh, perfect, Karen. Thank you so much for letting me know. All right. Uh, okay. Karen, why don't we do it? Why don't we do this like this? Why don't you just give me a green light and just let me know when I can start. You said three minutes more, so I'm guessing it's going to be at uh, at 9 at 9:40 at my time in 2 more minutes. But just let me know when I can go ahead and start. Okay, thank you. Yeah. Hi, Dr. Bot. Yes, yes. I think we did have a bit of a time mix-up, but that's all right. We're uh, I've I'm still here. I'm still here. We can do this all over again. No problem. Okay, so in just 1 more minute, I'll wait for yet another minute, and then we'll start with the tutorial. All right, it is already 11:40 p.m. Okay, right, we are ready to go. Perfect. So let's get this party started. So hello everyone. My name is Felipe. I'm going to be the instructor here. I'll be going back and forth between this presentation and the chat box and a few things. So if you have any question, please feel free to write. Please feel free to write any of your questions here in the chat box, and I'll answer him. I'll answer them over the video. So here's the outline of our presentation today. First, I'm going to give you, before we even start, I'm going to give you a motivating example. Like, what is it that's going to get us through this whole tutorial? There's going to be one big example. Afterwards, we're going to look at how to get started with Biogeme and the course packet and everything. We'll take a look at the input files. We'll learn how to actually estimate a model using Biogeme. Then we'll learn how to look at its output files. And we'll also learn how to make predictions using the estimates given to us by Biogeme. Then I'm going to give you a few small tests to play around and see if you can use the software on your own. And then finally, I'll just mention the assignments in passing at the end. So let's go on to our motivating example. The example here is we have a scenario where people are making a choice, a mode choice for their long distance trip. And the options available to them are car and air. And the variables impacting their choice are going to be the cost, the in-vehicle travel time, the out-of-vehicle travel time, and the frequency. So as you've already probably seen with Dr. Bott in class, one way for us to represent utility is to have these, is to write it out like this, and have each variable impacting each one of the modes. And this would be our first attempt at writing a couple of utility functions for those two modes if we're just considering these variables impacting our choices. Now, if you look closely at these two utility functions, we have the alternative specific constants and the beta for cost, the beta for in-vehicle travel time, the beta for out-of-vehicle travel time, the beta for frequency. If we look at this model, we'll notice that we have a few problems. First of all, we can't estimate beta car and beta air at the same time. We have to choose one of these two to set to 0 because we need one of these modes, one of these alternatives to be our baseline alternative. So in this case, I'm setting beta car to be equal to 0. I'm choosing this one and I'm going to just remove it from the model. I'm just going to say this beta car is equal to 0. And the other two problems are that traveling by car doesn't really have out-of-vehicle travel time or frequency. Out-of-vehicle travel time is the time that you would spend going to the airport and waiting at the airport for your plane to depart. That all adds up into out-of-vehicle travel time. And there isn't such a thing for the car. You really just exit your door and you get in the car. And the same thing for frequency. We can think about frequency for air travel. So there might be 6 planes a day, there might be 7 planes a day, there might be 10 planes a day to go to the destination you need. But cars, well, you just have the car there. There aren't 10 cars passing a day to pick you up. You just have your car. So this frequency variable doesn't really make much sense in this case. So just for our example, this is how we're going to write utilities for our two modes. The utility for car is beta cost times cost car plus beta in vehicle travel time times in vehicle travel time car. And the same thing for air, but air also has its own alternative specific constant. It also has out of vehicle travel time and frequency. All right, now let's just take a step back. We already know our motivating example. Now, I'm expecting that you have already downloaded the course materials and you've extracted everything into some folder in your computer. And inside your BioGym tutorial folder, you're going to find this examples and warm-up folder. This is where we're going to be working mainly today. You're going to be doing at the end of the class these three. You're going to be playing around in these three folders, but mainly during the tutorial, I'm going to be in this guy here. And I'm also expecting that you've already installed and you have BioGym open on your computer right now. So go ahead and open BioGym. I have it open right here. Open BioGym. You're going to click this next button here, and what you're going to do is you're going to select the second option, Bison BioGym, right here. These are different ways of running BioGym. I'm only going to talk about this one. This is the only thing that you're going to need really to play around with the course that Dr. Bott is teaching you, and for the homeworks and everything like that, the assignments. So when we click on next, we see that BioGym is asking us for two things, for two types of files, a model specification file and a data file. So what are these two things? Let's talk about each one of these separately. Let's first talk about the data file. So the data file, it needs to be in plain text. So it needs to be a regular text file, and it needs to be tab delimited. Let me open this up in a way that allows you to see what I really mean. Open with Sublime Text. So what this means is that I have, here is what the data looks like. It's just in regular text form. This program here is a regular text editor. I can even open this, open with, where is Word? Oh, I can even open this in Notepad. This is just a regular text file. And these spaces here, they aren't regular spaces. They're just a tab, not a space. So instead of looking at this data here, I'm going to put it in Excel. I'm going to copy it in Excel and paste it here, just so it's a little bit better for us to look at. So the data needs to be tab delimited, and BioGym is case sensitive. Please pay attention to this. BioGym is case sensitive. So see here where I have some columns that are all caps and some columns that are all lowercase. That makes a difference. So when you're using BioGym, you do have to pay attention to that. All right. Now our model file. Let's take a look at how that looks. Oh no, wrong one. So this is what our model file looks like. It has a few sections. These sections are divided by these square brackets, and you have like a certain keyword in square brackets. So I'm going to talk a little bit about each one of these sections in a little bit more detail in this next slide. So first of all, we have model description. This is just a short text describing what your model actually does. So in this case, we opened mode choice bl.mod. This is just a simple binary logic choice model. Choice. This choice section is where we indicate what variable in the data set is going to be used as the variable to indicate which choice each individual made. I'll show you what I mean in a second. Beta. This section here, this is very important. This section, beta, is where we set up the limits and the initial values for the estimation procedure. So here, we have, let me turn off word wrap. Here we have the alternate specific constant for air, the beta for cost, beta for in-vehicle travel time, beta for out-of-vehicle travel time, and beta for frequency. We're saying that we want Biogeme to estimate each one of these values, and we're setting the initial value right here. This is the initial value, and here we're telling it what are the limits of our search. So we want Biogeme to search from -1,000 or 10,000 to plus 10,000. It's a very wide range. Usually giving it these ranges is going to be exactly what you need. And lastly, you have this definition of status, 0 variable, 1 fixed. So what I'm saying is that all of these are variable. I want Biogeme to search and to optimize for all of these parameters. If, for example, I already knew a specific value that I wanted for the frequency, I would say, okay, I don't want this to be searched. I'm going to set this to fixed, and I'm going to set the value that I know right here. So minus 1.55, minus 1.57. So if I do this, if I change this line, this is going to set this beta to be always 1.57. Biogeme isn't going to try to estimate the coefficient for this for this parameter here, but it is going to estimate for everybody else. Okay, so let me undo those changes. Utilities. Here in the utilities section, this is where we define the exact utility of each of our alternatives. I have a slide specifically talking about that one. I'll go into more detail about that in a little bit. Let me see if okay. There's an expressions section here. Expressions. Here's where we create new variables that aren't available from the data. So you see here in this utility section, I'm referring to this variable called 1. Excuse me. I'm referring to this variable called 1, O-N-E. So what this is doing is it's looking in the data set for a variable called 1. But you'll see that we don't have a variable called 1 in the data set. What we're actually doing is that in this expressions section, we're creating a new variable called 1, O-N-E, and it's equal to the number 1 for all observations. So writing this here, 1 equals 1, is the same thing as doing this. Equals 1 for all observations. It's exactly the same thing. Sometimes it's interesting to create a variable called 1 or a variable called 0, which generally isn't in the data set. So I like creating those two. So let me just delete 0. 0 isn't really necessary for this exercise. So exclude. Exclude is a section where you're going to tell the model to just not consider some observations. So what am I talking about? Here I'm saying exclude chosen equals 3. So this data set was originally generated from choices between 3 alternatives. People could choose alternatives number 1, 2, and 3. But since this example I'm giving you is only between alternatives number 1 and 2, I want to discard all observations that have the variable chosen equal to 3. So I'm just going to not look at observations that have this chosen variable equal to 3. And then we have the model type, we have the model section, which defines the type of model being used. In this course, we're only going to use MNL or BP, MNL for multinomial logit, and BP for binary probit. And finally, there's this weight section where you can indicate a variable in the dataset to give your observations weights. We're not going to use this in this course, so I just wanted to add it in here so you know if you want to use a weighting in your estimation procedure, you can use this weight. So let's talk about the variable choice, the choice section, the utility section, and the expressions section. So first of all, choice is I've selected here choice. My choice variable is chosen. So the variable chosen is the variable that indicates what people actually chose in the data set. So this observation, this person here was presented with this in-vehicle travel time for car, this in-vehicle travel time for air, this out-of-vehicle travel time for air, this total cost for car, this total cost for air. And in the end, they chose one. They chose this alternative, alternative number one. Alternative number one is it refers to the car. Alternative number two, response number two, is related to air, and alternative number three is rail. So one is car and two is air. So that is where this ID comes into play here. So whatever people chose here in the data set, whatever's aligned with this variable chosen here, the number that they give you in the data set here, you're going to connect that number to the utilities up here using this ID. So ID1, car. So this person who chose car down here has is choosing this alternative that has this utility. This first person who chose alternative 2, they're choosing air, which has this utility over here. So what we're doing is just paying attention. What we're doing is just paying attention that the variable chose. We're creating a link between this ID here and the variable chosen up here. That's what these two sections do: chosen and the ID part and utilities. Also important is this availability section of the utilities. So see here that I've set this to 1. This is just saying that we remember that we created a variable called 1 that was equal to 1 for all observations. This means that the alternatives car and air are available for all observations. You could create a scenario where maybe the car isn't available to some people, maybe the air alternative isn't available to some people. That makes more sense when we're talking about maybe 3 or more alternatives. But if you wanted to play around with that and have a survey where you or have a data set where not all modes are available to all people, this is where you edit that. And finally, here we have the definition of utilities. This section here is where we're going to pay a lot of attention, and we're going to dedicate a lot of our time as modelers coming up with utilities. So the structure of this is always going to be one of the betas. Let me open it here in this text document. So the structure of this is always going to be one of the betas I created up here times one of the variables in my data set. Remember, this variable here I just created, and I put it and I added it to my data set. So beta from up here times something in the data set, plus beta from up here times something in the data set, plus beta from up here times something in the data set. That's the structure that we're going to use. So the structure that we build up here should line up with what we defined earlier in our motivating example. Remember when we said our utility of car is going to be beta cost times the cost of car plus the beta in-vehicle travel time times in-vehicle travel time for car, and utility for air is going to be all of this. We just write this in text form in here. So do we have any questions so far? Are we going all right at an okay pace? All right, let me just check if everything is okay. We have about 15 people. Okay, how to construct the data file. Some individuals are available to 2 alternatives while others are available to 3. So in this, I'll tell you, I'll get to that in a little bit. Well, actually, I can show you here. So we can do this. We can, in our data set, you're going to have to mess around with the data file. But suppose you had these columns: availability car, availability air, and availability rail, because those are the three alternatives that this data set uses. So most people, I'm going to set almost everyone to have one. So this means that everything is available for everybody. But it might be that for some people, only two of these alternatives are available. So you're going to fill these in with zeros. That's how you let people know. That's how you set the availability to these things for each mode. So now you have these columns in your data set. You have a column called availability car, availability air, availability rail. So you would have to come here and say, okay, so the availability variable isn't this ONE anymore. It's availability car, and it's availability air. Okay, does that make sense, Junbiao? So here we already have the availability for both of these guys, and this is going to be a variable that is in your data set. Awesome. So moving on, the exclude and the model sections. So the exclude portion, I already told you, since this first example is only looking at two alternatives, we just want to discard observations that have that variable chosen equals to 3. So what this command is doing is essentially just it's just deleting these observations right here wherever the variable chosen equals 3. It's just deleting these rows and continuing with the estimation procedure with all the other observations. Finally, the last thing that we're looking at is we're telling the software that we want to use an MNL kernel, a multinomial logit model. And you can set it to MNL for multinomial logit, or you can set it to BP for probit models. Just so you know, BioGene does not have support for multinomial probits. But you can use MNL. You can use MNL for both binary logit and multinomial logit models. So okay, we've already learned a lot about our data. We've already learned a lot about our model specification file. Now let's feed those two into BioGene, and let's run the model. So choosing the model choice bl.mod, that's our model file, and the mode data.dat. Let's click on apply. So code is running, and finally we reach our convergence. This is what we really want to see: convergence reached. This means everything went smoothly. BioGene was able to find an optimum for the estimation procedure, and everything worked as expected. So if you have another message here, that means trouble. It means you could have specified some problem. The model you specified has some problem, or there's some convergence issue. So now let's take a look at BioGene's outputs. When I go into the folder where I'm running everything, I see that a bunch more files were created in here. So there's an HTML file, and let's open that. So this HTML file gives me some log likelihood values, which are used in tests. I'm gonna talk about each one of these specifically in another slide. We have our row squared and adjusted row squared value. This gives us an idea of goodness of fit. This is similar to if you're familiar with linear regression. This is really similar to R squared. This gives us an idea of how well our model is performing when we compare it to a model that only has the constants. So it's how much better than the constant only model are we performing. Diagnostic, we have here convergence reached. That's what we wanted to know. That's great. And utility parameters. This is the important part. Utility parameters. This here is telling us what the actual values are for each one of these parameters in our model. So in our model, we said that we had a beta for the air variable, alternative specific constant for air. This table tells us that that estimation value, the biogeme estimated that constant to be minus 1.74. Here we have the standard errors for all of our estimates. We have the t-stats and we have the p-values for those estimates. So this is what you want to look at. It's like, oh, look how interesting. Frequency is positive. Well, that makes sense, right? If we have more planes coming by every hour or every day, I'll have the utility of, or the probability of someone choosing air is going to go up. And in vehicle travel time, the sign is negative. Well, that's also pretty understandable, because the larger the travel times, the less you want to use that mode. So this is great. This gives us a good idea of what's going on in our model. If you want to have some of the estimation results with a little bit more precision, you open this mode choice bl.f12 file. You can open this in a regular text editor, and you have this. This file is kind of ugly, so what I like to do is just copy this and paste it in Excel. So here what we have is the parameter name, the estimate, and the standard error. And here you just have the same numbers you had in that table I presented to you over here, but we just have a little bit more detail. We just have a little bit more decimal places. So this is good for, after you've estimated your model, if you want to play around and make some predictions. It's more interesting to use the numbers that you find in the F12 file rather than in the HTML file. And modechoice.sta, that you can also open in a text editor. That's just a really simple. It's a really simple text file that has some very superficial descriptive stats. Again, this is pretty ugly and terrible if you just open it raw. So I'm going to again throw this in Excel. So we have here some just basic statistics for each of the variables. Frequency for frequency for air. The mean value is 25. The minimum is 3. The maximum is 45. So just really simple statistics here. Number of times each alternative is available, number of times each alternative is actually chosen. So just really simple stuff, just to superficially analyze your data set. Do we have any questions so far? Are we doing all right? Okay. Okay, I'm going to check back in a few seconds, but for now, I'm going to continue. So I told you that I was going to tell you about all of these likelihood values. These values, each one has a specific meaning. So this first one, no likelihood. No log likelihood is a likelihood you get when you set all variables to 0. So remember in that, remember in our original model here, what happens to the likelihood when we set all of these betas to 0? All of these guys here, what happens to the likelihood when we set all of them to 0? It gets to minus 2.106. Sorry, minus 2,106. The constant log likelihood is what would happen to your model if your likelihood function only had constants. So instead of being 0 times all of these things, what I'm doing is Here, the constant log likelihood, I'm just considering the constant. The only thing in our model is the constant. The initial log likelihood is the log likelihood when we use the initial values set in the betas section. So remember here where we had a few initial values for these betas? These are the values that are being used to calculate this initial log likelihood. See that this initial log likelihood is the same as the null log likelihood? That happens because we happened to choose initial values for all of our betas to be all 0. That's why this likelihood, these two likelihoods are the same. And lastly, we have the final log likelihood, which is the likelihood after reaching convergence. When we use these values down here, that's the likelihood. Okay, so I see we got a question. While some individual associated variables are considered, how would the model ended? Good question. Good question. I do have a question about this at the end, so just hold on for a little bit, and I'll talk about this. I'll talk about this individual associated variables in a moment. But great question. So now think about this scenario. We already have our model estimated. We know the values of our betas. Now imagine if we have a situation in which there's a car trip that has these costs and travel times associated with it, and we have an air trip that has these costs and travel times and frequencies associated to it too. How can we use our model to predict the probability of a person in this situation choosing either car or air? How can we use the numbers that we just found to estimate to predict the probabilities here? Oh, that's unfortunate. Okay, let me just pull up everything. So first of all, we have the utilities up here. Remember, we defined these utilities up here from our model initially. So what we're gonna do first is we're gonna plug in the estimates from the model that we had before. Remember that we plugged in that we found the alternative specific constant to be minus 1.74 for air. The beta for cost is minus 0.000133. The beta for in-vehicle travel time was minus 0.0185, and the other betas are right here. So you just plug those in. And then down here, I'm just plugging in also the variables cost car that I gave you in that table before. So in that table before, I had cost car was 70, cost air was 160. In-vehicle travel time for car was 250, in-vehicle travel time for air was 60. So you just write all of this out and plug this in, and you're going to get a final result here. Utility for car is 4.63, and utility for air is minus 4.71. So how do we, after we know the utilities of these two guys, how do we calculate the probability of them for a logit model? So the probability for car is the exponential of the utility for car divided by exponential of utility for car plus exponential of utility for air. So it's very simple. We already have these two values here, so we just plug in minus 4.6 here, minus 4.6 here, and minus 4.7 here, and we get 0.52. This is about 52%. So great, we already have our probability for car, it's 52%, and our probability for air, we can just do the reverse, right? If this is utility of car on top, this is going to be utility of air on top. Or instead of doing that, you can just take, well, the only two possibilities are car and air, so instead of doing this calculation, you can just do 1 minus probability of car. So probability of air is about 48%. Now, if we're looking at probit models, things get a little bit different. I estimated a new model here. Don't worry about the values. This is just another short example, just so you get an idea of what to do down here. The important part isn't so much up here. Up to this point, it's all the same. You establish your utility function. You write it in Biogeme, you find the estimates for betas, and you use the variable values you want to plug in here, and you're going to get your utilities at the end here. So the question is, what do we do with these utilities? Utility for car is minus 3.4, utility for air is minus 3.5. How do we use these utilities to actually transform them into probabilities? So the probability for air is going to be, oh, actually, I don't like this. Let me change this a little bit. There we go. Minor change, of course. So the probability of using car is going to be phi, or phi, of utility of car minus v of air. It's just the difference of the two. And if you want to get the probability of car, put the utility of car first. So it's going to be phi of minus 3.45 minus 3.5, so it's going to be phi of minus 1.28. But what exactly is this phi here, this phi? This is the cumulative, this is the CDF for a standard normal distribution. This is the CDF for a standard normal distribution, or normal distribution with mean 0 and standard deviation 1. So you know that the CDF for the CDF for a standard normal at 0 is 50%. So 0.128, that's a little bit above 0, so it should be a little bit above 50%, and that's what we see. It's about 0.55 or 55.1%. So the probability for air is going to be exactly the same thing, but the other way around. So you're going to take the utility for air minus the utility of car, and then take phi of that. So just like we did with the logit case, instead of calculating this, we can just calculate 1 minus the probability of car, because the only two possible alternatives are car and air. So if we know that the probability for car is 55%, the probability for air is about 45%. And like I said, phi is the standard normal CDF, and here you can use these two functions in Excel 2010 or later, or 2007 or earlier. You can use these functions in Excel to calculate the standard normal CDF. This z value is what I'm calling this 0.128. And if you want to use R, you can also use just this p norm of z. That function also works. So do we have any other questions? Oh, so if we set any initial value for non-zero, that parameter will not be estimated. No, I can set any value here to be non-zero. I can set all these values to be 1.5, or I can say I want this one to be minus 1.5, I want this one to be 0.5, and I want this one to start off at 3.5, and I want this one to start off at minus 2. This doesn't change. These values, these are just the starting values. What defines if Biogeme is going to search for the optimal value is this status right here. So if I set this guy to 1 and this guy to 1, this means that this variable is locked at 1.5 and this variable is locked at 3.5. But the other variables, they're all going to be estimated by Biogeme. I hope this answers the question. Okay, so now let's make a small change to our motivating example. I told you that the data set was originally designed for three alternatives, so let's re-include that third alternative here. We have car versus air versus rail, and the variables impacting choice still the same: cost, travel time, and frequencies. So what we need to change in our model is we have to set this new utility for rail, and it's going to have its own alternative specific constant, and it's going to be affected by all of the other variables exactly the same way. And how does this translate into the Biogeme code? Well, I created this other file called modechoicemnl.mod, which already has all the alterations made to it, mode choice mnl.mod. So here you'll see that I've added this alternative specific constant here, and I've also added a new line in this section here in utilities. I created a new ID number 3 for rail, and this ID is this third alternative is just referring to people who chose alternative number 3. So let's go to Biogeme and get that running. Biogeme. One annoying thing is that every single time that you run Biogeme, you're going to have to close it and restart it if you want to run another model. So that's a little bit annoying, but you eventually get used to it. Okay, apply, run, and okay, convergence reached. Everything worked out fine. So it's exactly the same thing that we did before. And the values that we have are exactly, well, not the values for estimation, but the way to get to the final model, to get to the estimated model, is the same. And you'll see that that a few more files were created here in the same folder. We have the HTML file, which has our results. We have our F12 file that has our results with more precision. We have our STA file and a couple of other files that are being used. So, all right, I'm going to give you guys 5 minutes. Actually, I'll give you guys 7 minutes. I think that'll be enough time. And I want you guys to do these 3 tasks. I want you guys to first, in task A, create a binary logit model that people have to choose between car and air modes, but there's only the constants. No variables are going to be used here. We're only going to have the constants. Task B is create a binary probit model. So it's not a logit, it's a probit model. And people are choosing between car and air, also only using the constants. And the last task, task C, is you're going to use the multinomial logit model, and people are going to choose between car, air, and rail. And I want you to use these variables: IVTT, OVTT, total cost, and femsex. Now, Junbiao. Now here is where we should pay attention to that question that you asked earlier earlier today. Femsex. This is a dummy variable that indicates that the person is a female, or that the decision maker is a female. So this is a variable associated with the decision maker, not the alternative itself. So there is the way to create this variable, or the betas for this variable, are different for the ways that you're going to create the betas for total cost, OVTT, and IVTT. Remember, you should choose one of your alternatives as the base, and then create and have two other betas, one for each of the other 2 modes. But I'll first let you guys play around with this and try it for yourselves. And just a couple of tips for task A and B: just copy model choice bl.mod into the folders. So I've already created the folders for task A, B, and C. Here you have task A, task B, and task C. All 3 of them have the data file just copied again. So what you want to do most is copy mode choice bl.mod, copy it up here and copy it here, and you want to make some changes to it, and you're going to copy mode choice mnl and copy it here into task C and make some changes to those. So I'll be here. I'm going to set a timer here for 7 minutes while you guys play around with Biogeme and try to edit these files and try to get these 3 tasks running on your own. And I'll be here on the chat answering any of your questions. So does it have strict format for writing the model file, say as the alignment for the utility function, listing the definition names and parameter names? So, Junbiao, no, there isn't a very strict formal there isn't any strict formal structure. I like to leave things aligned because I like making things organized like this. The only restriction that Biogene does have is that you have to leave a space between your operators. So you have a variable, space, operator, space, another variable, space, operator, space. It's very tedious, but having these things helps. If you just copy these guys, you'll be fine. Up here, also no real structure. Just being divided by some spaces. You can have this all ugly. It's fine as long as the sequence of numbers, you know that this first one is the initial value, the second one is the lower bound, the third one is the upper bound, and the last one is the status. As long as you know that, you're going to be fine. I personally really like letting things super aligned because it just makes my reading of the model file that much easier. Yes, one space is enough. You see that I'm leaving here in some places two spaces, and that's just to make things align and just for them to be really pretty. But that's absolutely unnecessary. You do need to leave one space. Two spaces is just if you want to leave make things align. Okay, so I'll give you guys like 5 more minutes to play around. And if you have any questions, just let me know here in the text box. Okay, task A. All right. By now, I'm guessing most of you have already probably finished at least task A. So task A is a binary logit model only using the constants. So I can get rid of all of these betas right here, and I can get rid of all of this right here, and this is all I need to do. Just save this and run it in Biogene. Everything should be running just fine. Now, let's look at second one. Second one is I want a binary probit model with only the constants. All right, so what do we have to do for the probit model using only the constants? Well, exactly the same thing. I'm going to delete these variables here. I'm going to delete all of these guys here. And here in the end, you just set this to BP, binary probit. That's all you need to do. Save the file and run Biogene. Now the last one is the tricky one. And I know this might cause a bit of confusion. So let's do this one together. So here I want to add the variable femsex, right? So beta femsex beta femsex air beta femsex rail. So beta femsex rail q beta femsex air times femsex. And I'm going to do something very similar, but here it's rail. So remember that when we're talking about user-specific variables, we can't add them generically, right? Let me copy this here and give you an example of what I'm saying. I couldn't be able to do something like this. Have all of this here plus beta femsex times femsex. Why can't I do something like this? Why can't I do something like this? The problem here is that this doesn't change for a single person. Remember that when we're talking about utilities, the way that Biogene and the way that any model is estimated, we're looking at differences between alternatives, and we're looking at differences between the utilities of these alternatives. If this is the same for all three alternatives, this essentially becomes incorporated in the constant. This becomes a constant term that's added to everyone. So I will never be able to estimate this beta right here. So instead of doing it like this, instead of creating this generic beta that multiplies femsex, I have to do it the way I've defined it up here. So I select one of my alternatives to be the base. I'm going to leave that as being the car because it's already the base for my alternate specific constant, so I might as well be the base for this beta as well. And it's going to be that beta times the variable femsex. This beta for femsex in the rail times the variable femsex in the data set. So this is a little bit trickier. These are the kinds of things that you're going to be that you're gonna trip up on. This is super normal to get confused with, but you should be seeing things like these in Dr. Bot's course as well. All right, do we have any more questions? No questions so far, so let me go forward and get into the last part of the lecture. I know you guys are already tired. I'm sorry, this is a bit longer than I expected. But here are some just general Biogene tips. If you want to get data into Biogene format, if you want to work with Biogene with some other data set, a good alternative is to just work with Excel. Let's say here, open with Sublime Text. Let's say I had some data in Excel. And like we said before, I wanted to mess around with the availability for car, availability for air, air and availability air and availability rail. If I wanted to mess around with these and make some changes all around, what do I have to do to save this new data set? Well, the simplest thing you can do is select everything in Excel, open a notepad or WordPad or something like that. Just save it as a text file, and Biogeme will understand your data input. You can save it as CSV or TXT or whatever. Again, reminding you, Biogeme is case sensitive. So if you have a variable that is all lowercase and another variable that's all uppercase, Biogeme does make a distinction between those two. Like I said, please leave spaces for operators. Leave a blank space at the end of the line. This isn't always necessary, but I have had problems every now and again with this. So just leave a blank space at the end of each line, especially here in this betas section. Leave a blank line at the end of the model file. You'll see here that I have a couple of blank lines. You should not end the file on this line. It shouldn't be like this. You should have 1 or 2 extra lines down here, blank lines, so that Biogeme can read this line as well. And the model and the data files should be in the same folder. Like I created for you guys, we have like a bunch of different folders for each task. Just be sure that your model file and your data file are both in the same folder. And like I said earlier, if you want to estimate a new model, you're going to have to restart Biogeme and estimate that new model. If you want more examples and you want to learn how to use more complex models, more complex Biogeme models, you can access the Biogeme website. They have a tab for examples. Let me open that right now. Biogeme.epfl. Here, just go in examples, Swiss Metro. Here we have a bunch of example files that you can follow and you can download and see the output that's expected. They give you input files and they give you a data set to test it on. Here's the data set, and here are all of the input files for different versions of the models. The assignments, just a quick note, the assignments, there are 2 assignments. I've put them each in their particular folder, and I have already separated the data files for each of the assignments in those folders. This first assignment is just for you to get more acquainted with Biogeme and to understand, to play around with simple binary choice models. Here we're going in assignment 2. We're going to start looking at a bit more complex multinomial logit models. And that is it for the tutorial. Thank you guys so much for paying attention. If you have any question, please let me know. You can contact me at fdias@utexas.edu. I will be more than happy to answer any questions you might have. Thank you again for your attention. I'll stay around for another 2-3 minutes before I close the live stream, and feel free to, if you have questions, post them here in the chat box or send me an email. So again, thank you, and more importantly, just have fun with all of your modeling endeavors. Thank you. Yes, Guoyan. What can I answer? What can I answer about task A? let me open task A here. Could you do task A first? Sure. I have here I have the file open. This is what your model should look like. You're only going to have an alternate specific constant for air in your beta section, and this is what it's going to look like in the utility section. So there's nothing here. Okay, so now let's run this through Biogeme. Next, Bison Biogeme, model specification. Let's go to task A. Oh, okay. Is that it, maybe? Did I forget that? Let's see. Aha, I think I know what the problem is. Binary logic, just the constants. And mode data. Ah, okay. I know what's going on. So let's do this. The model doesn't like that we have this thing empty here. So let's do this. Let's create an alternative specific constant for car, which we know doesn't exist, and we're going to fix it to 0. So here I'm setting status to 1, and I'm setting the value to 0. So here ASC car being equal to 1. Okay, so I've saved that in the model file. And let's try estimating that again. Biogeme. Okay. Biogeme. Task A. Aha. There you go. So that's the trick. To get a model with only the constants, you are going to have to write down both of the constants, because it doesn't like Biogeme doesn't like the fact that there's you're giving it the instructions for a utility function, but then it's empty here. So give it some structure, but you're forcing it to be 0 all the time. You're forcing it to be 0 because you're setting this variable to 1. Thank you for pointing that out. And you should do the same thing for the binary probit model as well. You're going to, for task B, you are going to want to do the same thing. So you have this ASC for air. You're going to actually want to do that for car. Set that guy to 1, and have this here, ASC car. So I'm setting the alternative specific constant for car. I'm creating an alternative specific constant for car. I'm setting it to be 0, and I'm fixing it at 0. But still, I give some structure to the parameters here. Let's see if Biogeme is still complaining. Biogeme. Let's look at task B, binary logit. Actually, this is binary probit, but okay. And we have liftoff. It worked too. Great. I hope that answers your question. All right. It is 10:45. Thank you so much, Karen, for the heads up. I'll be leaving and shutting down the stream. Thank you guys so much again. and I'll be keep in touch if you have questions about Biogene. Thank you. Bye bye.